In the spring of 2026, an anomalous presence was detected in the vicinity of the Strait of Hormuz. It was neither a surface combatant nor a submarine. The electronic warfare suite aboard the USS Abraham Lincoln intercepted a faint and erratic signal. At that moment, the carrier strike group was holding station in the northern Arabian Sea. The signal's characteristics matched signatures that intelligence specialists had been tracking for several months. They were associated with Iranian-manufactured Shahed series unmanned aerial vehicles. The events of the following few hours would become one of the most strictly controlled and significant air defense engagements in recent naval history. Its importance lay not in the scale of the attack, but in how it demonstrated the tactical employment of unmanned systems in future conflicts. The USS Abraham Lincoln is a Nimitz-class nuclear-powered aircraft carrier displacing over 100,000 tons. The supercarrier was operating in the region as part of a scheduled force posture adjustment. She was escorted by the guided missile cruiser USS Mobile Bay and the destroyers USS Halsey and USS Stockdale. Together with logistics support vessels, they formed a layered defensive screen spanning a radius of dozens of nautical miles. The strike group had been placed on elevated alert status. The trigger was a series of Iranian military exercises in the Persian Gulf. These drills included simulated swarm attacks on naval targets using fast inshore attack craft. They also rehearsed the launch of drone swarms over the strait. The atmosphere aboard the USS Abraham Lincoln was characterized by extreme vigilance. The crew was standing by for a potential kinetic engagement. Inside the carrier's Combat Direction Center, the operational picture was saturated with data. The SPY-1D radars on the Aegis-equipped escort ships continuously scanned the battle space. They generated a recognized air and surface picture comprised of commercial shipping, fishing vessels, and air traffic within established flight corridors. However, anomalies began to bleed into this picture. Small radar contacts materialized at low altitude along the Iranian coastline. They would briefly gain altitude and then drop back down, as if probing the detection thresholds of the strike group's radars. This specific flight profile perfectly matched the characteristics of Shahed 136 loitering munitions. It is a delta-wing airframe powered by a small piston engine. It is capable of delivering a roughly 90-pound explosive warhead over a range exceeding 1,200 miles. By modern standards, the Shahed 136 is not a high-tech weapon. It lacks sophisticated targeting systems, relying instead on basic inertial navigation with GPS correction. The platform is incapable of active maneuvering or deploying electronic countermeasures. Its tactical advantage lies elsewhere. It flies low, it flies slow, and it is employed in numbers designed to saturate an air defense network. Naval surface-to-air systems were not originally designed for the simultaneous interception of dozens of low observable targets. The intelligence picture preceding this incident had been building for weeks. The National Geospatial Intelligence Agency had analyzed overhead satellite imagery. They identified an unusual concentration of launch systems at 3 sites along Iran's southern coast. These were located near the cities of Jask, Chabahar, and on Keshem Island. These were not fixed facilities, but mobile platforms mounted on heavy commercial trucks. Such launchers can be relocated to a new firing position in a matter of hours. Iran had previously exported similar systems for use by proxy forces in Yemen and Iraq. Human intelligence corroborated signals intelligence intercepts gathered by the National Security Agency. These intercepts indicated that the IRGC Aerospace Force had placed these specific units on high alert. Mission planning systems were loaded with coordinates corresponding to maritime targets. The USS Abraham Lincoln Carrier Strike Group was the most probable objective. The first confirmed launch occurred at approximately 2:17 local time. An infrared early warning satellite in geosynchronous orbit detected a thermal bloom on the coast near Jask. Seconds later, a second flash was detected roughly 7 miles to the east. This telemetry was downlinked to the carrier's Combat Direction Center via the JTIDS tactical network within 90 seconds. Almost simultaneously, the SPY-6 radar aboard the USS Stockdale, operating in volume search mode, picked up 2 low-flying tracks. They were pushing southwest over the Gulf of Oman at an altitude of about 1,000 feet, traveling at 115 miles per hour. The contacts were almost instantaneously classified as hostile. There was no filed flight plan and no transponder squawk. The subsequent actions unfolded strictly by the book. The Composite Warfare Commander, operating out of the carrier's CDC, initiated intercept procedures. These were executed under the strike group's Integrated Air and Missile Defense Framework. The Aegis combat systems aboard the cruiser and the two destroyers transitioned from search to track. The SPY-1D radars narrowed their beams to generate weapons-quality tracks on the inbound bogies. Simultaneously, the Air Wing's alert fighters were scrambled. Combat Air Patrol was already being flown by a section of two F/A-18E Super Hornets from Strike Fighter Squadron 115. A second pair of jets was catapulted off the deck within 8 minutes. However, the primary challenge lay not in detecting the drones. The core issue was the brutal economics of the kinetic kill. The production cost of a single Shahed 136 is estimated at roughly $20,000 to $50,000. A single SM-2 Block 3IA surface-to-air missile fired from a cruiser or destroyer costs around $2.5 million. An SM-6, capable of engaging more complex targets at greater ranges, runs over $4 million. The economic exchange ratio was painfully obvious to the strike group's command staff. If the adversary launches 30 drones worth less than $1.5 million, the cost of repelling the attack with standard interceptors would exceed $100 million. This is a deliberate feature of Iranian military strategy. The approach is designed to impose asymmetric costs and deplete the warship's vertical launch magazines. It forces the naval task force to expend its most expensive assets to swat down cheap expendables. Therefore, the response was structured in a layered defense, carefully weighing the cost per kill. The outer defensive ring was heavily reliant on electronic warfare. The SAWIP Block 3 systems on the escort ships began directional emitting. They targeted the specific satellite navigation frequencies utilized by the Shahed's guidance package. The jamming was calibrated to inject navigation errors directly into the drone's flight paths, all while ensuring the strike group's own GPS capabilities remained unaffected. The effects became apparent within minutes. Several tracks began to drift off their designated vectors, sliding eastward due to the degraded positioning signal. 2 contacts dropped completely off the radar scopes, likely ditching into the sea after total navigation failure. The second defensive ring employed kinetic, yet highly economical, means. The F/A-18E Super Hornets were vectored onto the surviving targets by an E-2D Hawkeye airborne early warning aircraft. The Hawkeye was orbiting at 25,000 feet, approximately 160 nautical miles to the northwest. Its UHF-band radar had been tracking the drone formation almost since launch. It continuously fed targeting telemetry via data link straight to the fighters. The Super Hornets closed to visual identification range. To prosecute the drones, the pilots relied on their 2 0mm 6-barrel rotary cannons. The rate of fire on this weapon exceeds 6,000 rounds per minute. The cost per round is roughly $30. Even factoring in the burst length, the cost to kill a single target was measured in the hundreds of dollars. 3 drones were shredded on the first strafing pass. A 4th was caught in the violent wake turbulence of a passing fighter, lost aerodynamic stability, and tumbled into the ocean. But the engagement was far from over. The first wave had been a reconnaissance in force, designed to probe the detection capabilities and defensive architecture of the task force. At approximately 2:48, a second wave of launches was detected. This time, the launches occurred simultaneously across all 3 previously identified sites. Thermal blooms indicated a coordinated salvo of 15 to 20 loitering munitions. They were ripple-fired with minimal intervals and were converging on the fleet's position from 3 distinct azimuths. This specific tactical scenario presents a severe stress test for naval air defense. A multi-vector swarm attack using autonomous platforms demands lightning-fast threat prioritization. The task force commander made the hard, tactical decision to strictly manage the magazine depth. The order was given to hold back the primary inventory of guided surface-to-air missiles to avoid catastrophic strategic costs. The approved defensive matrix dictated the use of long-range electronic warfare. Fighter gun runs and short-range air-to-air missiles were cleared for the mid-range intercept. The SM-2S and SM-6S were held strictly in reserve for any leakers that managed to breach the inner defensive perimeter. This calculus relied heavily on the inherent technical limitations of the incoming platforms. The Shahed 136 is a basic fire-and-forget weapon, incapable of adapting to a dynamic electromagnetic environment. It cannot dynamically reroute or distinguish a physical warship from an electronic decoy. To exploit this, the SEWIP suites were networked with the Nemesis electronic warfare system. This system projects massive, false radar and infrared signatures. It essentially generated a ghost fleet of phantom targets, completely indistinguishable from actual warships, to the drone's basic sensors. Several drones altered their flight paths and dove toward the decoy signatures. They flew harmlessly past the physical strike group and out into the open ocean. Other munitions, having lost their GPS fix due to the jamming, defaulted to a loiter pattern and began circling at low altitude. They were methodically picked off by the Combat Air Patrol. The Super Hornets executed low-speed gun runs, chewing the drones out of the sky. After-action reports would later confirm that only 4 airframes from the second wave actually breached the inner defensive perimeter. This zone is defined as the airspace within a 20 nautical mile radius of the supercarrier. 2 of those 4 leakers were splashed by RIM 116 rolling airframe missiles. They were fired from the point defense launchers aboard the cruiser USS Mobile Bay and the USS Abraham Lincoln itself. The RAM is a high-speed, infrared homing missile that runs about $500,000 a copy. It is the optimal hard-kill asset against non-maneuvering targets at close range. The remaining 2 drones were shredded by Phalanx close-in weapon systems. This is a radar-guided, 20mm rotary cannon operating in fully automatic track and engage mode. Both contacts were destroyed at a range of under 2 nautical miles. The guns fired for less than 3 seconds per target. Not a single drone made it within a mile of the carrier. Once the kinetic engagement secured, the battle damage assessment phase began. In the CDC, damage control confirmed 0 hits, 0 casualties, and 0 material damage to any vessel in the strike group. However, the operation did exact a toll in expended assets. 2 rams, several hundred rounds of 20mm ammunition, and thousands of pounds of aviation fuel had been burned. But the most significant outcome was the intelligence gathered by the adversary. Iranian forces were able to actively monitor how a US carrier strike group reacts to a massed drone threat. Radar operating modes, electronic warfare algorithms, and fighter intercept profiles were all recorded for analysis. By forcing the fleet to light up and defend itself, the suicide drones essentially acted as a massive intelligence-gathering probe. In the hours that followed, the strike group reconfigured its sailing formation and shifted southeast. They opened the distance from the Iranian coast to expand their reaction window against any follow-on threats. Additional strategic assets were pulled in to monitor the battle space. A Los Angeles-class fast-attack submarine repositioned to provide early warning of any surface or subsurface sortie. The U.S. Air Force scrambled MQ-9 Reaper hunter-killer drones out of Al Dhafra Air Base in the UAE. An RQ-4 Global Hawk high-altitude reconnaissance drone established a persistent radar overwatch of the strait. Officially, details of the incident were embargoed for 72 hours. This delay gave the intelligence community time to compile a comprehensive after-action report. The subsequent statement from the Department of Defense was highly sanitized and strictly neutral. It simply confirmed the successful defeat of an unmanned aerial threat in the Arabian Sea. The text deliberately avoided naming the state sponsor of the drones, leaving an off-ramp for diplomatic de-escalation. Tehran, meanwhile, leaned heavily into strategic ambiguity. Iranian officials officially denied any involvement, suggesting the swarm could have been launched by independent regional proxy forces. Simultaneously, media outlets tied to the IRGC published extensive op-eds highlighting the vulnerability of massive naval armadas to cheap drone technology. The incident served as a stark proof of concept for asymmetric naval warfare. Deploying autonomous systems that cost literal pocket change on a Pentagon scale forces a superpower to expend disproportionately expensive defensive effectors. The tactical takeaways from this engagement directly accelerated U.S. Navy modernization programs. The fielding of directed energy weapons was fast-tracked. This included the Odeon optical dazzler systems and the Helios laser weapon system developed by Lockheed Martin. These systems are currently being integrated into the Arleigh Burke-class destroyers. Their deployment drives the cost per kill down to absolute zero, relying solely on the ship's electrical grid to fry the incoming targets. Furthermore, the encounter validated the absolute necessity of a deeply layered defensive architecture, one that seamlessly fuses electronic warfare, kinetic interceptors, and directed energy systems to defeat the massed drone swarms of the future. If you want to stay updated on the latest shifts in naval combat and asymmetric warfare, hit the subscribe button and let us know your thoughts on the drone threat in the comments below.